Hello, everyone. I'm going to get our captions set up just a second. All right, welcome everyone. Thank you for coming back to week 2 of our EcoCareers Summit Series 2023. I want to thank my team, Courtney, Christy. They're on in the backstage. I apologize, I need to close a few screens. All right, I apologize again. So my name is David Corsar, and I manage career development programs here at the National Wildlife Federation, including this year's EcoCareers Summit Series, along with the higher education team and the larger education and engagement department. I want you to bear in mind 3 things as we go along with technology. Please bear with us during any glitches. With this 2-week event, we've already had a few. If you encounter an issue, please first try either refreshing the tab if you're joining via a browser, or closing and opening Zoom if you are joining through the app. Interaction, please take advantage of the chance to interact in the chat box as well as the Q&A box. The chat box is used to talk to us and to each other throughout the entire Summit Series. We really do encourage you to add your own expertise and ideas to the conversation here, and use the Q&A box to send questions to our moderators, which will be asked to keynote speakers and panelists at the tail end of their sessions. And third, NWF support. The National Wildlife Federation is here to support you as you develop your leadership and career skills at each life stage, from pre-K through high school to entering the workforce to further academic goals and beyond. And we hope you will explore and take advantage of those programs. I'll share my screen. And I want to once again thank my colleagues, Courtney and Christy, for helping pull off this event every year. We also want to thank our sponsors, our corporate sponsor, GM, as well as our college and university sponsors, College of the Holy Cross, Raritan Valley Community College, Rowan University, Towson University, and the University of Colorado Boulder. Before we start today, I want to give a quick overview of this week's events. Today we have a keynote speech by Asim Hussain, chairperson of the Green Software Foundation. Tomorrow, we'll be starting again at 6 p.m. Eastern with a film screening called Woodhood and an interview with the director of that film, Alex Cullen. And then on the 19th and 20th, we have 2 panels on the 19th, starting at 4 p.m. Note the different start time that day. Careers in Climate and Information Technology, followed by a workshop specifically on preparing yourself for careers in IT and sustainability. And then on the 20th, the last day of the conference, we have Habitat and Wildlife Conservation Day with a really great panel. And again, as always, followed by a workshop with detailed information on landing a career in the habitat and wildlife space. With that, we're going to bring in Asim. Asim is a developer, author, and speaker with over 20 years experience working for organizations such as the European Space Agency, Google, Microsoft, and now Intel, where he is the director of Green Software. He's also the executive director and chairperson of the Green Software Foundation, a global industry consortium with a mission to create a trusted ecosystem of people, standards, tooling, and best practices for building green software. Asim, thank you so much for joining us today, especially with the time that it is in London. I'm excited to hear about your work and your recommendations for young people pursuing careers in sustainability, technology, or really anything, since technology and sustainability can and should be a part of everyone's career path. So Asim, the digital floor is all yours.
Wonderful. Thank you so much for the introduction. Let me just share my screen, which I think I'm sharing. Hopefully I
Looks
am.
good.
Yeah, looks good. Yeah. Awesome. Thank you so much. Let me get my notes to the side. But just let me excuse me for 1 second, because I just need to finish off some other bits of work, because it's that time of year again where you have to finish off and publish my my social responsibility report. I don't really want to do it, but the lawyers tell me I've got to do this once a year. It's just a report I do to describe all the good things I did over the last year. Why am I a good person? The things I did that are good. How I did better than last year, and yeah, the things I'm going to be better at next year. So yeah, I think yeah. Sorry, I've got a lot of this stuff going on at the moment. So yeah, I just have to finish. Yeah, it feels pretty good. So yeah, I'm quite happy about this. I'm going to just uh file download. I want to save it as a PDF, because PDFs are amazing. You can just send PDFs to other people. You can attach them in emails. I love PDFs because I live in 1994. And what's really good about PDFs is you can send a PDF to someone, and just if you want to send them to a specific section or point them to something, you just say, oh, just open up page 393, and halfway down the left-hand side, you'll find the section I'm talking about. If only there was a way to put information, on the internet, so that you could link. That'd be amazing. Just link to specific sections with a link and share that. It's almost like I don't really want this thing to be read. But anyway, that's just I just had to finish off my social response. I'll post it to my MySpace profile later on. But I might have to jump back to that a few times during this talk, just because it's just a lot going on. So yeah, so I'm here to talk about what I call tasty carbon trees. It's kind of very early thinking in terms of what a future for what we call a kind of this new field of kind of green software expert. What does that really look like, and what would they be doing in that type of role, which is a new role that is manifesting. This is a very emergent field, very nascent field. Yeah, the talk is going to talk about a little bit about what's emerging as a process for a green software expert if they were to engage with or be hired by a company to analyze their software. So yep. Thank you for the introduction. Asim Hussain, Executive Director of the Green Software Foundation, Director of Green Software at Intel. You can find me through all these various links. You see the word green software in a bunch of different places. So I've really been looking at sustainability, but through the lens of a software developer for many, many years now. I've been a software developer all my career, and the questions I've been trying to ask and help answer is, as a software developer, what do I need to do to be more sustainable? Not in my personal life necessarily, but in the work, and the thing I do 8 hours a day, however many hours a week, however many days a year. What do I need to do in my actual job to make my work more sustainable? That's kind of the questions that I've been asking. So I want to talk about today, I'm going to really dig into what is green software. You heard the term green software. What does it really mean? I'm going to talk about the explanation for that. And I'm going to talk about, and this is again, I'm on a cutting edge of a nascent field. So a lot of the stuff I talk about the concepts are just being formed. Sometimes some of the stuff just doesn't land, and this will disappear in a couple of months' time. Sometimes maybe what you're hearing today will be the de facto book and standard in several years' time. We'll see. But there's kind of a way of thinking about the space which is evolving into what we either call the 3 M's or maybe the 4 M's. It depends how many M's I can get away with in a talk. But it's about measuring. Actually, the real start would be modeling. It'd be modeling, measuring, and monitoring. But for this talk, I'm going to start with measuring, because that just makes a bit more sense. Measuring, modeling, then monitoring. And at the end, I'm just going to give a bit of a summary as to what was said in this talk. I think there's a chance for anybody to ask questions. Just ask away in the Q&A section, or at the end. And if there's any questions, I'll try and answer them at the end of the talk. Let me dive straight in. Okay, so what is green software in the first place? Because green can mean many, many, many different things. There's two. The first confusion people, no, confusion isn't the right word. It can mean multiple things. The first divide that people have when they think about green software is, are you talking about software which you build that makes the world more sustainable, i.e. software, green, or agriculture technology, things to kind of help people do ag tech a bit better? But you could argue that's green software. What we focus on is software itself is an emitter. The thing we're focusing on right now is carbon emissions. Water is coming up as a close second. But how software itself is an emitter of carbon emissions. What can you do to actually make software emit less emissions? And what we say is there's kind of like 4 pillars, 1 core pillar and 3 kind of main like sub pillars of green software. The first one is the idea of carbon efficiency. And you're going to hear the word efficiency a lot from me. Efficiency. So efficiency means, emit the least amount of carbon possible for every unit of work. Everything we do emits carbon. I'm breathing, I'm emitting carbon. Giving you this presentation is emitting carbon. So the goal as a green software expert, green software practitioner, is just to build systems which for every unit of work just tries to emit the least amount of carbon possible. If that is our kind of thing we're aiming for. Is whatever decisions you're trying. Sorry, someone tries walking. Whatever decisions you're making, if you're certain that the choice that you're making just has slightly less carbon emissions, pick that choice. And eventually, if you keep on picking that choice, you'll get closer and closer and closer to zero. That's kind of the idea of carbon efficiency. That has 3 sub-pillars. One is called energy efficiency. So energy is the biggest emitter of carbon emissions in the world. So consuming less energy in your software means you're emitting fewer carbon emissions. Another one is called hardware efficiency. So use the least amount of hardware possible. So, in a server environment and in a kind of web environment, you just want to use the least number of machines possible to service this website. We're having a streaming conversation through Zoom. We want to make sure that you're using the fewest number of servers, fewest number of machines necessary to actually service this conversation. That concept is called hardware efficiency. And the last one is really interesting. It's a very, very new area, and it's called carbon aware computing. And it's basically doing more when electricity is clean and less when it's dirty. So kind of responding to kind of signals that we can get regarding how clean or dirty your electricity is, how much is currently coming from wind and solar and lower carbon sources. Suddenly, maybe a lot more coal and gas is getting burnt. Maybe put the brakes on your application and kind of do less. That's called carbon aware computing. These are 3 different things that you need to do to make your software green. Let's dive straight into the first one, measuring. Let's see how long the multiple M joke I can make it last. If I was in front of an audience, I'll be able to judge whether these jokes are landing. But I can't, so I'm just going to keep on saying them. So here's a really interesting kind of thought experiment I give to people. So imagine you are imagine you've just been hired by a large corporation as the software sustainability lead. Q1, you're so excited. You measured the carbon emissions of your software product. It's 34 tons this quarter. All right, it's not great, but it's all right. You initiated like a lot of projects, like 4 or 5 projects to kind of reduce those emissions, make things more efficient. You very excitedly remeasured in Q2, and the carbon emissions increased to 52 tons. Should you be fired or promoted? Should you be fired or promoted? 2 extremes of an option there. At first think you might just say, well, obviously the guy or the person should just be fired, like they increased, they didn't do a good job. But then let me say, well, what if your colleague, the head of sales, did a stellar job? and double the number of users that are using the product. So really, it probably should have been 68 tons, but you only made it 52 tons. That's a different way of looking at it. If you're in the software space, the thing to understand about the software space, it is high growth. Everything in the software space is either, if you're employed in the software industry, you are employed on something that's growing. Very few people are employed to look after the products that are in decline. If you are being employed, you're being employed by a product that's growing, because that's where the money is, that's where the growth is. So that's just a fact of your life. So that's just the environment you're in. You're in this high growth environment. And so in that environment, how useful are totals? Totals, like the thing to get about this is a total is just one metric. Like if you're the CEO of a company and like you don't just get one number every month and you look at it and you go, wow, this one number tells me everything I need to know about my organization. No, you have dozens, hundreds of different measurements and metrics, because the different metrics tell you different things and they give you different information and they can drive different decision making. So one of the challenges I see in the sustainability space is that we all try and lump everything into one type of metric, one sum total of carbon footprint, and we try and like make that be the one metric which matters. And the one thing to learn is that that's not that useful. What we find a lot more useful, or what perhaps is a lot more useful, is a rate. That's another way of thinking about it. So what if you didn't measure a total, you measured a rate? What if it was 3.3 grams per user, and through all of your effort and energies, you got down to 2.9 grams per user? Yes, the total number of emissions has increased, but what you're doing, what you invested in, the projects that you kicked off, they're doing good. Some good is happening. So carry on investing in them. Maybe you'll get a promotion. But it's pointing you, it's giving you information about you are doing good things, carry on doing those good things. And that's kind of what metrics are there for. That's one of the reasons why you want to measure. So you don't just want one metric. Metrics kind of give you information. And if a metric isn't helping you make a decision, you probably shouldn't be measuring it. If you're measuring something and it's not actually helping you make any decisions, it's just red tape. And that's one of the things we've developed in the Green Software Foundation is something called the Software Carbon Intensity Specification. And I'm showing you an equation. But this is like a specification that's been built by a working group of people through consensus. And it's been designed as another type of metric other than a carbon footprint, a more useful metric that developers, software teams need. As you can see at the end, per R, so it means it's a rate. So what would a per R be? We're doing a zoom right now, and we're doing a zoom. So a STI score for zoom might be carbon per minute. The total number of Zoom users and total emissions of Zoom might increase over time because Zoom is growing. But the carbon per minute of Zoom should hopefully be going down month by month by month by month if you're tracking that metric, and that's a sign that you're doing good things. So this metric is actually the important thing about this metric, and I think is that it was the way it was developed and designed was the behavior we wanted people to exhibit came first. The behavior we wanted them to exhibit came first. The equation came second. What everybody wanted to ensure was that the three behaviors we know that make software green, making it more energy efficient, making it more hardware efficient, and making it more carbon aware, the metric just drove those three behaviors. And that's, I kind of think, really important thing to understand about measurement as well. Oftentimes you're given these metrics and measurements, people kind of focus in so hard on trying to calculate a value, but they don't think about what are the behaviors that measuring that metrics are driving. And I think that's one of the really important lessons that we've learned, is that what are the behaviors that a metric drives? The only way to reduce this score is, if you just look at it, the only way E is energy you consumed. If you reduce E, that number goes down. M is your hardware that you're using. If you reduce the amount of hardware, the number goes down. The I's are as a measure of clean and dirty electricity is. If you use cleaner electricity, I is a lower number, the score goes down. The whole equation, the only way to reduce your score is to have the behaviors that we want, that we could. The behaviors are not an accident, they're an intentional aspect of the system. So many times in the past, I've seen so many people. I myself have spent ages kind of you all gather together at the end at the every year to calculate your corporate social responsibility report, and you try and calculate the carbon emissions of your organization, and everybody works really hard to calculate that number to kind of like X decimal places, and then you all file, save as PDF, share it to the rest of the world. You go, well done, everybody. See you in 11 months. We'll do it again. But in that intermediate 11 months, that measurement doesn't really drive the behaviors. The behaviors just happen, and the measurement just happens. One isn't related to the other. So here was like an intentional effort to drive behaviors, because what people do is when you give them a metric, what people do is they figure out, well, what levers do I need to pull? How does this measurement work? What levers do I need to pull to make that number go lower? Okay, I'll do the things that make that number go lower. Metrics drive behaviors, and the behavior is what you're trying to drive. Hopefully that's coming across as a really important thing to understand. Another really interesting part of the SCI, and I think there's another manifest this in an interesting way as well, is that the team decided to only allow eliminations. Let me just explain what's going on this slide for a second. If you're reducing emissions, if you're saying that you're reducing emissions, there's actually a couple of different ways you can actually say you're reducing your emissions. There's abatement or elimination, and then there's different types of offsets: compensation avoidance offsets or neutralization removal offsets. Let me give you a real life example of what this looks like. So let's say I'm taking a flight somewhere. And I want to reduce the emissions of that flight. Abatement elimination would be not taking the flight, or picking an option of maybe a plane that's more efficient. Efficiency is abatement. Efficiency is not emitting. That's what efficiency means. Maybe I pick a different traveling option or something like that, which really reduces the emissions. That's abatement and elimination. If I'm not going to do that, I'm going to take the flight as is. My other options to reduce emissions would be to purchase offsets, which are kind of financial instruments. A compensation avoidance offset is like somebody else is saying, I'm definitely going to fly 100% for certain. I'm definitely going to fly. Pay me some money and I won't fly, but I'm definitely going to fly. So then you pay them some money and they didn't fly, and they definitely said they were going to fly. As you can imagine, there's challenges with that approach. Neutralization removal is like you're paying somebody else for some mechanism which sucks carbon from the atmosphere and puts it away somewhere, planting a tree or whatever other technique there is. That's neutralization removal. The SCI, and kind of the way we've decided to calculate, is only eliminations are allowed. And that's again because if you allow offsets as part of your calculation, you incentivize different things. Again, as I said before, measurements, how something gets measured, drives the behavior at the other end of the equation. I've had organizations, none I've worked for, don't go into my LinkedIn and find out. I've had leaders of organizations reach out to me and say, Asim, I'm really finding it hard to have conversations inside my organizations about investing in anything to do with efficiency, because my organization has just announced that it's carbon neutral. And carbon neutral means buying a whole bunch of offsets to nullify your emissions, so effectively zero carbon. And they're telling me that I can't really talk about reducing carbon emissions because we're apparently at zero carbon already, and you can't go less than zero carbon. So what's happening in that situation is that measurement criteria they're using, you're allowing offsets. And so what you're incentivizing when offsets are 10, 100 times easier to do than elimination. Making something efficient is incredibly hard. buying offsets is incredibly easy. So if you're giving people an option to do the two, they'll usually pick the offset option, which means if you're trying to incentivize and prioritize energy efficiency or some of this other stuff, you'll end up incentivizing the purchasing of offsets instead. So if you just eliminate, you don't allow that in the first place, you just force everybody to just do elimination. So yeah, really important lesson is it is all about how you measure, because how you measure drives the behaviors that you want to achieve. So yeah, different measurements incentivize different behaviors. It's very important. That's one really important thing to recognize. Different measurements incentivize different behaviors. If you allow things like energy offsets, people hate when I use energy offsets, like renewable energy in your measurements, it's harder to incentivize energy efficiency. If you're trying to like convince somebody to invest, $1 million into your project to make something more energy efficient, and they can invest $100,000 in just making all your electricity renewable, that's what they'll do. But the amount of carbon emissions that's going to the atmosphere is still high. So if you're allowing kind of offsets in your measurements, you're incentivizing different behaviors. And kind of this idea of there's different types of measurements. You can have totals, rates, other things. They'll just tell you different things and they incentivize different behaviors. That's measuring. Let's talk about modeling. What is an application? What is a software application? Well, it's not a fridge. I know pretty certain that a software application is not a fridge. You can look at a fridge. You can see a fridge. You know, just by looking at it, you know everything that's contained within it. If you try to write a report saying these are all the carbon emissions that this fridge emitted in its creation, and you send that to me, I could look at that report and go, you missed the door. And you go, oh yeah, the door, I forgot the door. Okay, here's the page, the door. Oh, silly me. And you're okay, fine, that's everything. You can judge, you can rip off the door and kind of break everything into its components and kind of dig in and kind of see what's going on. There's what we describe it as is it's got a clear boundary. Just by looking at it, you know what's contained. There's air, then there's a fridge, right? So you know what the boundary of the fridge is. What is the boundary of software? And this is kind of where the world gets really confused because, you can't really close your eyes and kind of wrap your head around what software is. And it doesn't really have a boundary that is like so clear to define. It kind of gets fuzzier and fuzzier and fuzzier and fuzzier. And then it just becomes philosophical debate at some point saying, is that an application? I don't know. So one of the things I've seen historically at least, is like when people they have been writing kind of reports of like, what are the carbon emissions of a software application? And you look at these reports and you look and you go, oh, what is that? Okay, did you include the screen? A lot of time when people do these reports, they just do what was the CPU and the chips on your computer. They just ignore the screen. Go, okay, you included the screen. Did you include the network? Because you're using a network to get data. Network causes emissions. It's just a computer like anything else. Did you include, you're coming from some server and some data. Did you include the server in the data center? Did you not doing that? Did you include this and that and the other? So it's quite challenging to understand what is the boundary of a piece of software. That's why because you can't see it, and because you can't just naturally infer it by just knowing what a product is, you have to write it down and you have to do what we call modeling. So it's one of the things we do when we talk about the SCIs. You can't just say, oh, I've done my app, I've done the calculation, it's 3.3 grams per user. No, you have to actually say, what are the different components? This is the boundary of your software. You really have to sit down and list it out. If you were doing like a life cycle analysis for a fridge, you would have to do that for a fridge. You'd have to literally write out all the different components of a fridge, all the different things that make it up. And it's easy to do that because it's a physical thing. With software, it's a lot harder and it's a lot more, it's difficult to look from a report like this to understand what was missing because you don't know what people haven't included. And so the way the scores work is just you add up all the SEI scores for each component, and you sum it up to the top, and it adds up to the top. And what that allows you to do is, like, let's say somebody else, like let's say I've created a product, and then I announced, I did all the calculation, and I announced, I told the world, my green software practitioners that I've hired, and they've calculated all these numbers and they've published them out. And a competitor comes along and go, well, we've done the same thing, and ours is 0.3 grams per user, more efficient than your product. Nah. This is what happens all the time right now, and people are saying our products are more efficient than your products, but then it's really hard to compare softwares. But by defining what we call a model, and kind of listing out all the components, you can then clearly see that a company too went, where's your database? You skip that out. You skipped out that database. Did you skip it out on purpose just to, get that little bit of an edge on the score? Or maybe maybe this is your own product, and in year one, you very publicly announced 3.3 grams per user, but you're under so much pressure year by year to show that you're improving, that in year two, you just did some nice little gerrymandering of a border just to cut out, hey, we're not going to use the database anymore. With software, you really do need to have what we call a model, a definition of the boundaries, just so that we know what you're comparing. So you can compare like for like. You can maybe compare Google Meet to Zoom. Maybe they should both do a report like this, so you can compare, and you can actually see what did they include, what did they not include. So you can do a real like for like comparison. And this is maybe the fourth muzz, but you can do maybes. So once you've got this model, this is one of the things. This is how I think this role of a green software. We don't even have a great name for it. We're calling it practitioner right now, but green software expert in organizations is going to grow. We believe that the first step would be you'd be hired, and then you would do a model. You'd take their application, you would sit down, you would model it, which is kind of the left-hand side there. Then you would measure it, so that doing each of these little calculations, so you actually figure out what each components kind of emissions is, and summing up to the total. You'd be hired to do that. And then the next thing you would then do in your role as a green software expert is kind of use this model to then predict, well, if you did all this work on the servers, you could actually probably decrease it by 0.3, and this would be the impact that it would have. So this is kind of the maybes. You could do some what if scenarios just by having the model. This is a little bit different. This is we're now getting to the point where software has its advantages, because it's not a physical product, and you can do this kind of crazy spreadsheet type, guesstimations. This is where I think this field is going towards, is you're going to have people that sit there, they model, then they're going to measure, and they're going to maybe and do what if scenarios, and try and convince organizations to put investment into certain projects to make things more efficient. I've never seen a major green software feature from a major company be prioritized without a ton of modeling, without somebody doing a ton of modeling and saying, if you were to do this work, if you were to invest X millions of dollars into this project, this is the impact you would have. So this is why these maybes are really important. So just to review, software is not hardware. There's no edge. You don't know. You've got to figure out hardware boundaries are easy, software boundaries are hard. You need to model software. You need to clearly define what's included and excluded. And once you model, you can let your imagination run wild and can do what if scenarios, and without writing any code, without making any changes, making recommendations to organizations for how to implement changes. And the final one is monitoring. We're heading very much into where I really think this is not a lot of people are thinking the way I'm thinking here right now, but I really think the future is monitoring. I'll explain what I mean by that. So, actually, I forgot. I completely forgot. I need to add my yearly calorie count in Asim's social responsibility report. So every year as part of my report, I completely forgot. Every year as part of my report, I have to calculate how many calories I ate for the whole year. And it takes me a long time because I have like I use a very detailed calculator. I use a very detailed spreadsheet to make this happen. So I apologize for this. I really do need to calculate this. It's gonna, it's very complicated. I just maybe. Okay. So I'm just going to copy that. So I just need to add it to my report. Where should I put it? Things I did that are good. Here we go. Reduced calorie consumption to boom. Okay. I'll have to I'll post it to my MySpace page again. Why? Driven by why did I do this last year? Why am I consuming less calories? I don't know. I moved my desk. It used to be over there, so a couple of steps, fewer steps to the fridge. I started running, but then I also stopped going to the gym. So I suppose that trades off. Let me check my calendar. Oh, I went hiking last Thursday. Maybe it was the hike I did last Thursday. So I was, I'll fill out later on. Ugh. Okay, I'm gonna need a bit more time to do that one. But yeah, just imagine this. Like, imagine for a second measuring something once a year, and then trying to figure out all the things you did in the previous year, which might have caused those numbers to change, right? When we're doing these kind of, and a lot of regulations is now forcing organizations to do a yearly accounting of the carbon emissions. But then you're trying to figure out, well, yeah, they went down, but then what did they do? Which project drove it down? Like, imagine for a second, like algorithmically tuning like your fitness regime through one comprehensive measurement a year. You might get your fitness goals, but maybe not before you die of old age, right? This is actually how we used to build software. We used to build software in kind of what's called like a waterfall model. A lot of people still do build it with a waterfall model, but maybe you'd release something once a year. Like, different products would release like their version once a year. And then imagine your world in the software space. Like, you work really, it's like hundreds of people are working for a whole year, making thousands, tens of thousands of changes. And then on one day you release the new version and you get like 1,000 bugs come through. And then your job is to figure out which of those tens of thousands of changes over the last year caused these bugs, right? You have to like figure that out. It's incredibly challenging, right? And so the model that a lot of organizations now either have moved to or are striving towards is what's called continuous integration, which is, as you develop and as you make a change, pushing it out to the world as quickly as possible so you can see if it's working or not, and you get that feedback. So for instance, Facebook is famous for this. So Facebook, how many people uses Facebook? Billion, 2 billion? I don't know. Facebook releases code changes every few hours. So every few hours, all the code changes that have been done in the last few hours get pushed out to everybody. What that means is if there's a problem, pretty quickly because a lot of people are screaming. But you also know pretty quickly that if there are any bugs, it's probably only going to be because like the 10, 12 changes that are pushed in the last few hours. You probably know you can pretty quickly point to the code change that caused that problem. You get that very tight feedback loop, because that's really what it's about. With the waterfall model, you have a very loose feedback loop. You're getting information, you're getting feedback once a year, and you're trying to optimize based off of one feedback once a year. With the continuous integration, you're getting feedback constantly. You're getting feedback straight away, as quickly as possible. And then you're applying that feedback very quickly. And that's making you optimize and improve at a much faster rate and get better and better and better much faster. What if, this is the key thing, like what if organizations calculated a real-time feed of their carbon emissions like just like a stock ticker? You know, this is what we call monitoring, not measuring. It's called monitoring is when it's a real-time number that's just ticking all the time. Like with a stock ticker for a company, like if the stock price like moves like 0.01%, you know, 15 articles get written trying to like figure out like what drove that change. Or if someone does something bad, like the stock price goes down straight away. It's like it's giving you information about what's going on inside your company that you can then use to kind of make decision making. What if a company was reporting minute by minute the carbon emissions they were emitting? What changes would that bring? What behaviors would that drive? And I think that's the important thing to understand. Kind of one of the things that I focus in on, and the foundation focuses in on, isn't like measuring for measurement's sake. It's changing, it's driving behaviors. What are the behaviors we want people to drive? And one of the feelings we're getting right now, I'm definitely getting it, is that if we tightened up that feedback loop and made it more real time, I think employees of an organization would feel a lot more empowered to do stuff. If you are making changes today and tomorrow you saw the impact of that change, how much more empowered will you be to make changes, to make positive changes inside your organization? You would learn much faster. You would learn much faster. You'd know the impact. You're a leader. You've invested in a project. You think it's going to do good stuff. You'd know very quickly whether that project's doing good things or bad things. Whether you need to tweak it, kill it, or whatever. You know, you get that information much faster. And if we're trying to hit kind of climate targets in a very short time span, I honestly don't think yearly numbers are even remotely in the ballpark of what we need. We need real time, minute by minute. That's how we're going to accelerate the transition. And this is, again, something that I believe, like a green software practitioner, I believe when you're hired inside a company, you're going to model this application. You're then going to measure their application. You're going to figure out how to measure each and every one of the software components, get all the data together. But measurement is kind of a one-off snapshot. The next stage is like plugging that into real-time data. So then you're measuring every minute and publishing every minute. That, I think, is the three M's of the future world of green software practicing. Yeah, so just a review. Yearly reports mean learning is going to take decades. Tighten that feedback loop, you know, monthly, weekly, daily, hourly, even every minute is what's needed to accelerate kind of optimizations. Monitoring, not measuring, I believe, this is my prediction, monitoring and measuring is the future of sustainability. Whether you're talking about software sustainability or anything, I think it's the future of sustainability. Summary of everything. So just to remind you of all the things I've just said. I think I'm well over time. I do apologize. So green software is more energy efficient, hardware efficient, and does more when electricity is clean. Measurements drive behavior. That's a really important thing to realize, is measurements drive behavior, because people learn what levers to pull to optimize a number. So a measurement, that's what a measurement is driving behavior. It's very specifically for software, you know, create a model so that you know what you're measuring. And if you want to accelerate the optimization process, we speed up the feedback loop. So it's all about monitoring, not measuring. And that is the message I wanted to get across today. Hopefully I got it across. I don't know if there's any questions or if I've gone over time, but yeah, thank you very much for your time.
Thank you so much, Asim. I do have one question, and that is, so you're talking about things that are very cutting edge and being formulated now, and whether it's a green software practitioner or expert or manager, what would be how would you describe the best way to prepare for something like that? If a student is in high school right now, or even in college, and hearing about what you're presenting here and saying, yeah, this really resonates with me, and I want to be one of the people that's pushing that forward. What kind of advice would you give to them?
So the first thing I would always say is, we've actually, like, one of the things we've created is just some I should have put it in the links actually, So if you get to learn.greensoftware.foundation, we actually have some kind. It's just 2 hours. It's not long. It's like 2 hours training. But you can actually get like a certificate from the Linux Foundation for completion by clicking. It's all free. All of it's free. And it's actually now also in Italian, which I'm really excited about. But so that is, this training kind of first gets you in the helps you understand even a lot of the terminology that I'm talking right now is kind of not taught. A lot of the language, a lot of the stuff about energy is just not taught typically in a lot of these environments. This kind of helps you get on everybody on the same page. There's a lot of places I could point people to, but I would also again point people to, like, if you go to the Green Software Foundation website and just join our newsletter. And I do apologize, it just really is that this field is just so new and nascent. Any advice I give right now on this call might be old in 6 months' time. So if you join the newsletter, we send out a weekly newsletter where we just point everybody to the latest information and also latest learnings, latest trainings. We are creating kind of like a much more fuller certification, which will take like several months to learn and train, and we'll give you like the one we have right now isn't going to get you a job, to put it bluntly. The other certification is going to be a lot more effort, and it's going to be something which is going to be a bigger signal that you have an employable, you have the knowledge to be useful to an employer from day one. So that's kind of the area. We're not quite there yet, but that's the area that we're going towards.
And if you didn't recommend signing up for the newsletter, I would have. It's a really great newsletter, and I think today it was either today or yesterday the focus was on the carbon impact of AI. Just really great issue. So definitely recommend that everyone check that out.
Thank you. Yep.
Well, Asim, thank you so much for your presentation. Really fascinating stuff. Really good to get ahead of this kind of development within sustainability, and really helps. I think a lot of the youth that participate in our program are really aware of greenwashing, and this is one of those things that you can't get away from it when you're presenting transparently this information, this detail. I love your example of the fitness tracking, calorie tracking, and I'm going to suggest that to my trainer. But no, really, what's going on here is really great, and is an inspiration. And so thank you again for participating today. And if any questions roll in from folks viewing the recordings, I'll send them your way.
Wonderful. Thank you so much. Yeah. Thank you all. Bye.
Take care.